Hey everybody, today we are going to do trigonometry lesson number 4. We are down the home stretch here. We only have a couple lessons to go in this chapter. And trigonometry 4 is dedicated to all of the people who were really sarcastic, and when we do the law of sines, they're like, yeah, well, if there's a law of sines, does that mean we're going to do a law of cosines too? Yes, this lesson goes out to you. That's exactly what we are going to do today. Now, if you don't know why we need a law of cosines to go along with a law of sines, I understand. And ultimately, the need for it is going to take care of itself. I don't need to tell you why we need the law of cosines. All I need to do is start example number 1, and you're going to see why. If you know the law of sines, then as soon as you see example number 1, you're going to realize that we need the law of cosines. Okay? So here we go. We've got angle A is 62 degrees. Side B is 56, and side C is 40. Okay, so on the law of sines, the rule was always set up a ratio with the letter that you know everything about. So we look over here and we ask ourselves, okay, which letter do we know everything about? Which letter do we know both the sine and the angle about? And you look and you're like, well, we don't know side A, we don't know angle B, we don't know angle C. The answer is none of them. We don't have the complete story about A, B, or C. And since we don't have the complete story about A, B, or C, there is no way to set up a ratio using the law of sines that will help us get this problem right. Okay? So that would be a pretty big problem. So we can't use the law of sines. That means we need to use the law of cosines. Now, when we use the law of cosines, there are 3 different ways to set it up. As you go through your work, you'll begin to learn some of these. It looks a little bit like the Pythagorean theorem in the beginning, so that shouldn't be a terribly big surprise to you to see the first part looking like it does. And then we just throw in some cosine business. Now, the reason it looks like this, long story short, I could talk about this for 30 minutes, but I won't, is that the Pythagorean theorem itself only works on right triangles. So, if you're not using a right triangle, you have to adjust the Pythagorean theorem to make up for the inaccuracy. And that's why the law of cosines looks like the Pythagorean theorem, but then it has another part at the end. Now, the reason it's written 3 different ways is because if we are not dealing with a right triangle, then A, B, and C are interchangeable. You know, on a right triangle, I've taught you forever that the hypotenuse is C. But if it's not a right triangle that we're dealing with, then it doesn't really matter which letter you call what. All right, so before we apply the law of cosines here, we have a special request. My daughter would like to do another joke today, so please welcome to the video Miss Cora.
Where do naughty rainbows go? Prism.
She told me that one yesterday. That was a really good math joke. Where do naughty rainbows go? Prism. Ha ha. Good job, Cora. Okay, so let's get going on this problem. Now, the reason we need to use the law of cosines again we need to know the complete story about a letter before we ever do the law of sines. So if we knew side A, then we could then use the law of sines to figure out the other bits of stuff. That would be really helpful. I think we should consider doing that. So let's give it a shot. Now, if we want to know side A, it means we should use the first version of the law of cosines, because that is the one that has the a squared equals part. Now, you're going to be really intimidated when you begin this problem, because if we try to set it up, it's going to look ridiculous. It's going to say a squared equals 56 squared plus 40 squared. That's not a squared symbol. Minus 2 times 56 times 40 times the cosine of 62. Oh, man. This is where the calculator is so worth it. Watch. I don't want you to do any of this separately. If you have this type of calculator, that's great. If you have basically any calculator that has a display where you can kind of see things as you go along, just type it all in. So even though the law of cosines looks like one of the most intimidating lessons that we've done all year, most of the time it's actually easier than a lot of the other lessons we've done because the calculator does all the work for you. So 2632.77. Now that's not actually the side length we're looking for, obviously, because if that was the side length that we were looking for, then that would be really, really big. So we need to take the square root of that because what we had on our formula was a squared. So we're going to do the square root of a in s, and we are going to get 51.31. There you go. Now, at this point, we can switch our brains over and we can set up the law of sines. We can use the information that we got from the previous part of the problem and we can set up the law of sines. And that's the one where we're going to do sine 62 over 51.31. You know how the law of sines goes. If you don't know how the law of sines goes, go back and watch the Trig 3 video. Equals the sine of, you know what, I'm actually going to do C over 40. Now some of you might be wondering why I chose C instead of B, and it actually has to do with a video that I showed my accelerated kids. Maybe if you're a subscriber, you opened it up just because you were curious, or I don't know. The law of sines does very strange things with obtuse angles. It doesn't really work all that well for obtuse angles. So, I'm going to, whenever I'm deciding which part to do next, I'm going to pick the smaller side because the smaller side is going to be connected to the smaller angle. And the smaller angle can't be obtuse. So doing the law of sines works way better when you're dealing with acute angles. Okay? So my choice of doing side C instead of side B was not a coincidence. I chose it to be that way on purpose. Okay, so we'll do this. Divide both sides by 51.31. I don't have to type in 51.31 because I still have the answer saved from the previous problem. And that gives me 0.6883. And then, to figure out the missing angle, remember, we have to use the inverse function. There's a little symbol for that, but I did not find it on the computer yet. All right, there you go. I don't have to type that in because I can just hit the answer button again. 43.50 degrees. Okay, so the inverse sine of that was 43.50 degrees. And I don't have to do the law of sines anymore because now that I know 2, whenever I know 2, I can always just subtract from 180 to get the third. And that would give me 74.50 degrees. All right, looks good to me. I know it seems like it's a problem that takes a while. I mean, it does take a while, but I think I also sometimes, you know, that first problem just seems like it takes forever because you're trying to explain exactly what's going on. So don't get overwhelmed. We're going to get really good at this. Remember, one quick note. You never have to do the law of cosines more than once. All right, let's do example number 2. We've got angle B is 100 degrees, just like the temperature in Phoenix. Pretty much every day for the last like 6 days. All right, side A is 12, side C is 13. We do not know the complete story about any letter. Remember, if we want to use the law of sines, we need the complete story about a letter. We need to know all of a letter, both the angle and the side. We don't know that right now, so we are going to do the law of cosines, and we are going to use the version that has the B out in front. Okay, so we're going to use that version. And we're going to say B squared equals 12 squared plus 13 squared minus 2, 12, 13 cosine of 100. All right, then we're going to, I'm going to have to scroll up so I can show you. There you go. And then we're just going to punch it in. Now remember, the law of sines looks worse than it is because the calculator will take care of everything for you. All right, there you go. B squared equals, oh, what was that number? It was 367.18. Obviously, we don't want b squared. We want b, so we're going to have to do the square root of that number. $19.16. There you go. Looks good to me. I didn't actually write that on the last problem with my 51.31, but there you go. I'll just sneak it in there. Nobody will ever notice. Okay. So now we need to move on from there, and we need to try the law of sines. Now, the habit I want you to get into is to always use the smaller side. In this case, it won't actually matter. I know that both remaining angles are acute because the obtuse angle was already used. So we're going to take the ratio that we already know, this time I put it on the right. I'm not really sure why I did that, but it doesn't matter. And we're going to put it equal to the ratio that we don't know. So that's going to give us 12 times the sine of 100 equals 19.16 times the sine of A. All right, so now we're going to divide both sides by 19.16. Cross that off, so this is going to look really similar to what we've already done. And I'm just going to hit the answer button here because that number's already there. Okay. .6167. And then remember, we have to do the inverse sign if the angle is the thing that is missing. So we're going to get the calculator to do the inverse trick. We get 38.08 degrees. All right, now I can scroll up, finish the problem. It won't take more than a second from here because we've got that, and then we could just subtract from 180 to get the last angle. All right, and we're done with that problem. We get 41.92 degrees. All right, there you go. Now we're in a groove. The second one went way faster than the first. And we can move on to problem number 3, which is going to involve the third version of the law of cosines. Okay. So the third version was the one that looked like this. I am going to paste it down here so that you can see it, and then we are going to use it. Okay. All right, so let's take the information we have, let's throw it in. 42 degrees, 22, and 35. All right, so it would be really nice if we had the complete story about the letter C. So that's what we're going to do. We are going to try to solve for the letter C. That means we're going to use the third version, like I said. And we're going to get C squared equals A squared plus B squared minus 2 times 22 times 35 times the cosine of 42. So again, the law of cosines, just like I said before, it is a really, really intimidating looking problem, and then it turns out it's really not that bad. All right, there you go. Throw it in there. And just to save us some time, I'm going to just do the square root thing right there. Okay, there, and we'll get it all done in one shot. 23.76. Boom. All right, so once we have that, we're going to go to the smallest side, and we are going to do the law of sines with it. So we're going to say sine of 42 over 23.76 equals, and the next smallest side was A, so we're going to do sine of A over 22. Okay, hopefully we're getting in a really good groove here. These problems, if they seem to look the same, they do. The only difference is which version of the law of cosines you have to use in order to get the process going. So we divide both sides by 23.76 because that's what's going to get the sine of A by itself. Once again, we're going to lean hard on the calculator here. 22 times the sine of 42, close the parentheses, and divide by the answer from the previous problem, and you get 0.6196. In order to figure out angle A, remember we're going to do the inverse function here. So we're going to do inverse sine of the answer, and that's going to give us 38.28 degrees. Now this is actually a problem where had we done B first, we would have actually gotten our answer wrong. So that's kind of a weird thought. So I just want to make sure you're aware of what I said before. When you jump from the law of cosines to the law of sines, you need to go with the smallest remaining side first. Because again, the law of sines does some pretty crazy things with obtuse angles if you are not careful. Okay, so go from there. 99.72 degrees. Perfect. All right, so we took a little while to introduce the law of cosines, maybe a little longer than I wanted to. So I think I'm just going to compromise with y'all here. Today's assignment, number 4. There you go. That is today's assignment. You need to prove to me that you know how to do the law of cosines. Make sure you show your work. and then we will move on to the back tomorrow. All right, thanks for watching. Appreciate it. Take care of yourselves, take care of each other, and I will see you next time.